Hi everyone. I think Mikhail has introduced me already, so let's go to the subject of my presentation. Today we're going to speak about Intel OpenVINO product. This acronym means Open Visual Inference and Neural Network Optimization Toolkit. So this is a number of instruments to accelerate your neural networks and algorithms of computer vision on Intel platforms. If you stay with our track from the beginning, you heard Mikhail's presentation about the variety of our platforms. So today it's not just central processors, but we also have graphics FPGA, and we call it GPU or vision processing units that are offered under Intel Movideo's brand. These are specific devices to accelerate deep learning. Thus, the first main advantage of using OpenVINO is high performance on all these devices. And apart from that, in order to have acceleration of your models in Intel, you do not need to be well aware about how hardware is operating. You do not need many years' experience in optimization. You need basic skills in development in C, C++, or Python in order to have an advantage in terms of productivity. And apart from that, another important advantage is that our high-level API is single for all devices we support. Let's imagine that you need to port code to port your network from the central processor to FPGA, for instance. And without OpenVINO, you need to spend too much money to hire a specialist that is expert in FPGA. I do not think that there are a lot of experts like that. Or you need to sort this out, how it works on your own. This is also a challenge because you need to know how FPGA operates, how to work with it, and also learn about low-level development languages. I think it might take too much time and effort. And OpenVINO, porting the code from one device to another, is just 1 second, and you need to change one line of code where you put the title of your device. And let's look inside OpenVINO. Here we show all components of the toolkit. They can be split into 3 large groups.
The first is a traditional approach to computer vision, and the second, which is the most comprehensive, the main one, devoted to deep learning. Also, we have additional complementary instruments and libraries. From the very beginning, when it started, it was fully devoted to computer vision. Now we are distancing from that, expanding OpenVINO capabilities. We even have operator support of speech recognition, and also VINO can be used for other purposes very easily. Thus, in the section devoted to traditional computer vision, we have only one component left, but a component, well-known library for computer vision, OpenCV, and I think that it doesn't need any new popularity. It gets the code from the hub. We have certain guidelines and options for Intel platform and for their processors, and we provide it as packaged. Let's get over to the main and more comprehensive part, which is deep learning. And when we talk about deep learning in OpenVINO, we mean inference deep learning. I like more to say inference, and that's why I will continue it this way. When the network is trained to solve certain tasks Thus, we believe that you already have your network trained as a framework, and you can train it independently, or you can take it from the internet, or use our open model Zoom we are going to talk about today, and using the instrument, one of the main instruments of OpenVINO, which is called Model Optimizer, to transform it from a framework into the format you're going to further work with, which is called intermediate representation, and I put it in this bucket. And the second model optimizer function, I'm sure you've guessed from the name of the instrument, which is optimizer. And at this stage, the platform is independently, which is good for it. You can use IR for different devices. Also, using our API for Epiton, which is called inference engine, we can use this IR to be integrated for the final system and to accelerate it depending on the device you choose, you select. For you to better understand the principle of this S-engine, we provide the sub. So the next thing is Open Model Zoo. I have 2 slides devoted to Open Model Zoo. So I'm going to say just now that it's a certain set of trained models of those who are trained inside Intel. Let's now pay more attention to the instruments which belong to the deep learning group. The first one is the Deployment Manager tool, which is good being collecting the skills of and package of deep learning, the working package that you can install on your final device with the components you need. For instance, if you work at an IT system where the question of memory is quite an important one, and you cannot drag a big package of OpenVINO, you can use the deployment manager skill, which will collect only the components you need and the files that you can add there, like models. The next instrument is called Post-Training Optimization Toolkit, or POT. Now, optimization is popular with lower precision, which is accuracy. This toolkit is needed for the model from the full accuracy or full precision, which is can be FP32 or 16, to be transformed into int8. Low precision. Then I think the benchmark app, very important instrument, because here we are talking about productivity, but where will you find indicators for the productivities? The right numbers you can use using the benchmark app at your system, with your data, with your model. Which is a recommended way to measure the productivity with OpenVINO using our hardware. All instruments that I've enumerated, Model Optimizer, Deployment Manager, and POT, and Benchmark app, they all have an interference of command line. I know that there are people who love it, and there are those who are against it, and that's why we decided to combine those small instruments into one convenient interface, which is called Deep Learning toolkit. And the last one is Deep Learning Streamer. And I'm sure you know about this deal streamer. And it allows you to create out of plugins a pipeline for video research, which can use decoding or processing of video, or inference included, or coding. So Deep Learning Streamer is a set of plugins to integrate into the inference OpenVINO in the pipeline. And let's get over to the complementary instruments. You can identify Intel Media SDK and video research, video analysis, which is first to decode the incoming video flow and then to do the inference. And to do it in the best of ways, you can use Intel Media SDK, which accelerates whatever is related to coding video, decoding, coding, and some processing. The idea is to load the data of operation into the integrated Intel graphics, and you can kill two birds with one stone here. There's special units, expansion, which are very fast at producing those operations. And also, while GPU is busy with coding or decoding, the central processor is free and can be used for other needs, like, for instance, inference. If you want to use MIDI SDK, and if would like to use inference in graphics, so you need graphic driver, OpenCL driver, and if you use Windows, you can load it from Intel.com. But if you selected Linux, then it will be in the package of OpenVINO, and this will allow you to install it. But if you selected FPGA, we have a special package for that in OpenVINO with streams to upgrade the frameworks and special runtime. Let's go deeper to how our main instruments, model optimizer and inference engine, are operating together. At the input, you can have your trained model in the format of one of the frameworks. It's TensorFlow, Caffe, or NX, or whatever. So there might be a question, and where's the popular one? Well, it's the negative answer, by the way. We don't have PyTorch direct support, but I can say that you can use the PyTorch and convert it into the ONX to work further. And a couple of releases ago, we added some support to inference engine, and you can skip this step using the mode optimizer and start working with inference engine right away. Inference engine, in its turn, depending on the device you selected, will use its own plugin. For each hardware, we have our own plug-in in inference engine. For central processor, it's this one. For Movidius, it's Myriad plugin, and the Myriad plugin is used when you have chip Movidius only one. But if you have a card with several chips, then you will have to use AIJN plugin, because it contains certain scheduler to balance the tasks inside the card between the chips. So I haven't talked about such apparatus unit as GNA and unit accelerators. It's a special unit at CPU which can be used to process speech, to recognize speech, and so on. So we have our own plugin for that. Every component of OpenVINO contributes to acceleration and optimization, and we saw that Model Optimize does some independent operation like fusing of layers. In inference engines, we have optimization with plugins, and API inference engine provides additional opportunities and capabilities to accelerate the networks of your apps. For instance, it's a synchronous execution, and if your app consists of several parts like processor, changing the size, and inference, then you can do it parallelly. And to reach parallelism of inference, I recommend use a feature which we call throughput mode. The idea is to share those videos divide into several parts to do inference parallelly. Besides, here on the slide you can see multi-device plugin, which is also a very important feature. It's to use several devices simultaneously. For instance, if you have a heterogeneous system which has a central processor, and also, for instance, if you have more videos, then using the multi-device plugin, you can thus use all those three devices for your inference. And also, I will show the benefit for you using the multi-device device plugin. Now let's get over to another method of accelerating your neural networks, which is using low precision or computing with lower precision. Let's talk about what we can offer. First of all, I would like to say that without hardware support, this feature does not provide a very fast acceleration, but we do have this support, which is called Intel Deep Learning Boost, with special guidelines in the hardware, which can compute convolutions very fast. It's the vector neural network instructions, VNNI, on the new graph, which we now have on the 11th generation of processors, called Intel Xe graphics, which is DP4A. From the point of view of software, we have a low precision runtime in inference engine for computing with low precision computing, and besides operators and software. And for instance, for you, you have to convert it into such a model. Then you can use post-training optimization toolkit. The peculiarity is that you don't have to retrain your model to teach it in the format with lower precision, but in some cases, still you will need it, the retraining, if you are not okay with the final precision or accuracy of the model. It can happen. And in this way, we are recommending to use neural network compression framework, which is NNCF, which is not a part of OpenVINO, but you can find it in GitHub. Why at all I'm paying so much attention to low precision computing and our technology, deep learning boost? So here is the answer on this slide. It's the higher productivity than you can have using this technology. We here compare the newest process which has this technology, it's both graphics, and compared to processes from the previous generations with no technology such as this. And you can see those dark blue columns showing how fast this model will work. Light blue is showing how faster the model will operate in graphics, is DP4A, and yellow and the highest column shows the synergy from the joint operation of central and graphic processors using multi-device plug-in. And certainly the DL boost and is used here. Now, the next OpenVINO component, which is Open Model Zoo. We have a public models here you all know and heard, like model downloader, and we have here models that are trained here by our algorithms teams. So they are solving a narrow case, like recognition of vehicle signs or vehicle plaques. For you to better understand how to use them, we provide e-demo with each of the models. Open Model Zoo it has become so big now, so it's not good to put it into the whole package, but you can load it using model downloader to verify the accuracy using your data using accuracy checker. And here I showed several examples of our models, and those are the screenshots from demos. It's recognition of people from several cameras, identifying people, segmentation, and recognition of patterns, for instance, with textiles, of American language in gestures. We have also recognition and identification and super resolution for pictures and data. And also assessing the posture. Here we have 3D on the slides, but we have 2D. But this is a very tiny piece of what you can get from the open model zoo. So here is how deep learning workbench looks. And you can experiment with different parameters of TransEngine, like number of asynchronous tests, streams, and Workbench will provide you visualization of your experiments, and also it can do it layer by layer to tell you which layer took more time. And you can also use here models from Open Model Zoo. And do it in int A8, and also there's a more unique opportunity for you in Workbench. No other OpenVINO has it's the convolutions, which is very good for the speed of operations. And the recent features of Workbench is remote profiling. So you install it in one special system to do the measurement in one or several systems of your target. OpenVINO is a product with open code. Excluding some of the components, like, for instance, SPJ, which is closed yet. And you can visit our page, and our engineers are committing well, they are developing things there. It is called OpenVINO Toolkit, where you can find quite a lot of different repositories, even more than you can get from our webinar projects. And you can OpenVINO and inference engine, auto model zoom, and there, as I said, OpenVINO training extensions, not yet. If you liked some of the models from Open Model Zoo, maybe it is trained using other data, you can go to train extensions to retrain it using your data set. For instance, if you like the operations of our model to recognize the vehicle plaques or vehicle signs, so we use Chinese signs, and it cannot work with Russians, but you have your own data set in the Russian language, and you can easily retrain it because all the instructions and guidelines are there in the training extensions. And there are more high-level interface with the data where you can get from there. CVAT, computer vision annotation tools. So if you do yourself, you can use this repository because it's a semi-automatic instrument for the data, and for instance, you can use different scenarios of classifications and editing the facilities and objects. One of the recent added there was Data Tomorrow, which is a data management framework. It's software to store and manipulate the data sets. That is why our page in GitHub, you can find instruments to cover all your pipelines with trainings down to inference with OpenVINO. If you liked my story and the OpenVINO, so you're welcome to Intel Deep Cloud.com, where we have our infrastructure with a long list of different Intel platforms, several central processors models with graphs, with PGA, and cards of my videos at some of them. And OpenVINO already is pre-installed there, and you can go there to see it, which is right away there, and there are the benchmark until you can now see the productivity, compare with the productivity of your model, and maybe start writing your own application using OpenVINO. And here I prepared some of the links, and I'm sure you will have the presentation. You will get the presentation, and there are some disclaimers with numbers of productivities, and we can now do the Q&A. Thank you very much. Thank you very much for your story about the powerful tool sets. And now there's the main question. Port OS, is it available? Yes, absolutely, that's available, and we have special package for Mac where you can install it and work with our OpenVINO and Intel hardware. I have my own question. In OpenVINO, you have visual information reference to the early epochs of development of AI. And besides working with video, neural networks, and pictures, what other types of tasks OpenVINO can do? Okay, thank you very much for your question. Actually, we are actively working at the speech recognition, and speech-to-text, and a lot of other things. And even we have a special GNA unit at CPU, which allows us to effectively process such data with very low energy consumption. Well, inference engine is a library which it can accelerate the network, and I'm sure using OpenVINO is something you can do, especially in recommended systems. Yes, GNA is a part of general Intel Smart Sound technology in our Intel Core CPU, client CPU. So, and if you are going to launch it in voice assistant, don't use to use this accelerator and the functions of accelerator which are available now in the hardware.
Дополнительно покупать и делать не надо. Просто выбирайте инструментарий.
You just select the instruments and use the whole potential. Thank you very much for your presentation, Anna.